comprehensive explanation of Kubernetes Components Workflow. The Kubernetes components work in harmony to manage and execute user requests, such as deploying a pod or querying its status. Here's an in-depth walkthrough of how the components interact to fulfill a user request, ensuring consistency, scalability, and reliability. 1. User interaction. The workflow begins when a user interacts with Kubernetes using a tool like kubectl or another CLI interface. The user submits a request, such as deploying a pod or creating a service. This request is sent to the API server, which acts as the central hub of Kubernetes. 2. API server processes the request. The API server is responsible for 1. Validating the request to ensure correctness. 2. Authenticating and authorizing the user. 3. Updating the etcd store with the desired state of the cluster. For example, when a pod is requested, the pod specification, desired state, is stored in etcd, the Kubernetes key value store that maintains the cluster state. Controller Manager monitors state. The Controller Manager continuously monitors etcd for changes in the desired state. When it detects a new pod specification in etcd, it communicates with the scheduler to assign the pod to an appropriate node. Controllers, such as the replication controller or node controller, ensure that the actual state aligns with the desired state. 4. Scheduler assigns pod to a node. The scheduler identifies the best node to run the pod based on various criteria, such as resource availability, CPU memory, node taints and tolerations, affinity or anti-affinity rules. Once a node is selected, the scheduler updates etcd with the pod node binding. 5. Kubelet detects and starts pod. Each node in the cluster runs a kubelet, which acts as the node agent. The kubelet monitors etcd for pod assignments on its node. Upon detecting a new pod assignment, the kubelet 1. Fetches the pod specification from the API server. 2. Instructs the container runtime, e.g., Docker containerd, to pull the required container images and start the pod. Container runtime initializes the pod. The container runtime is responsible for pulling container images from the specified container registry, creating and starting the containers as defined in the pod specification. Once the containers are up and running, the runtime reports their status back to the kubelet. 7. Kubelet updates pod status. The kubelet collects the pod status, e.g., running, pending, and reports it back to the API server. The API server updates etcd with the latest status of the pod, ensuring that the cluster state remains consistent. 8. User queries pod status. Users can query the status of the pod using commands like kubectl get pods. The API server retrieves the pod's current status from etcd and returns it to the user. Key components and their roles. 1. User, kubectl CLI, submits requests and queries using commands like kubectl. Acts as the interface between the user and Kubernetes. 2. API server, validates, authenticates, and processes requests, serves as the primary communication hub for all Kubernetes components. 3. etcd, cluster state, stores the desired and actual state of the cluster, provides a consistent source of truth for all cluster operations. 4. Controller Manager, ensures the cluster's actual state matches the desired state by monitoring etcd. 5. Scheduler, determines which node should host a new pod. 6. Kubelet, node agent, monitors and manages the node's resources. Interacts with the container runtime to ensure pod creation and status updates. 7. Contain comprehensive explanation of Kubernetes